Great. Well, thank you all so much for joining us for this morning's program, Asteroids, Comets, and Near-Earth Objects. There's a lot of natural debris in space. Depending on their paths, composition, and locations, they have been assigned different names. They are mostly harmless, but this morning we're going to find out what they are, how they affect the Earth, and what NASA is doing to study them. NASA Solar Ambassador Regina Conrad will discuss the NASA mission's double asteroid redirection test, also known as DART, and the Near-Earth Object Wide Field Infrared Survey Explorer, also known as NEOWISE. I love these acronyms. Conrad, so Regina started as a weekend planetarium educator back in 2005 at the Andrus Planetarium in the Hudson River Museum in New York after her first total eclipse. Solar eclipse, which I somehow misspelled solar. I don't know how I do that. Okay, well, I should have edited this. In 2011, she was invited to speak regularly at the Stanford Museum and Nature Center before the Friday night observation. And now retired, Regina is a solar system ambassador with NASA, and she's also, I love this, a part-time library program coordinator for a small New Hampshire library. So all 80 of us or so, let's give a big virtual round of applause to Regina for joining us this morning. And Regina, you can take it away. Thanks so much.
Thank you so much for having me. The asteroids, comets, and near-Earth objects. Since the very beginning of time, people have looked up in the sky and saw the stars, the moons, the planets, the sun, and comets and meteors. Yeah, where's my arm? Yeah, there's a meteor there. They knew that the sun, moon, stars, and comets were slightly different because they moved. They moved. Sorry about that. Oh, it's only sharing the screen? No. There we go. They moved. The planets moved in the sky, so they could tell that they were different. However, they did know about comets in the 1600 BC. There are records in China saying that they were aware of comets. And there were actually recordings of the location of comets' tails in 600 BC in China. Comets were studied and looked at throughout the ages, and there were pictures about them. The one on the left is a tapestry done in 1066 during the Norman conquest. And they were considered good omens and bad omens, depending upon who won the war. And this is the other one is a drawing from the Book of Miracles from a 16th century German book. Aristotle and the Greeks had all sorts of theories about the comets. Some of them thought they were planets. Others said they couldn't be planets because they weren't in the ecliptic or the zodiac area of the sky, which is where the planets and the sun and the moon are. But then they had to be the other thing that they also knew is that there were very many people, or a few people, who thought that it was a heliocentric society. But it couldn't possibly be a heliocentric, meaning that everything went around the sun, because if the Earth was turning, everything would fall off. So that was just one of the theories. So they weren't all myths in the ancient days, but their ideas were not always accurate. We know that the comets orbit the sun and not the Earth. They are basically dirty snowballs. So when you see them with a telescope, it's kind of fuzzy and it has a bit of a tail. It is very likely that it was being hit by the comet that brought water to the Earth. In 1705, Edmund Halley predicted that this comet that had been traveling, that had been documented for several hundred years, was going to come back in 1758. He used the laws of motion that Newton had devised. And lo and behold, 76 years later, the comet did arrive. Now, we look at this graphic here. These are the orbits of the planets, which are fairly much parallel to one another, effectively in the same plane. I'm usually talking to people so I can tell people where a plane is. 3 points to find a plane. Whereas the comet is definitely an much more elliptical, and is tipped into the plane. So the planets are here, the planets are here, and a comet's going to come up in that direction. And just to point out, our dear friend Pluto is not in the same plane as the rest of the planets. The other thing we want to look in this side is that the tail of the comet is always pointing away from the sun, and that is due to the solar winds. So Halley said it was the planet was going to come back, or the comet was going to come back, and he ended up dying before 1758. So the people thought it was a good time to have a party and make some money. So they did celebrate the return of Halley's comet, and they were very excited when it actually did come. They named it after him, and some enterprising people went and made pills so that you would not die from the gas that the comet was going to give off, which didn't they must have worked because nobody died from it. Comets do not fly in the sky, meteors do. Comets actually stay in the sky for, depending upon the comet, anywhere from a couple of days to a couple of weeks. This particular comet back in 13 was only visible in the northern hemisphere for a couple of weeks. And it's the comet Pan-STARRS. And it was only visible just after sunset and just before itself set. So on the, you can see this over the course of a couple of weeks. It moved north in the sky, and it could be seen. Basically, it looks, this one particularly looked more like a jet stream. But you take a telescope and you can see a little more. And I think that was in 13, was the comet Conrad. And they were able to, or we are able to plan and know exactly where it's going to be on which day and where to look, and you're going to be able to see it. This one was done with a telescope. And Hale-Bopp in 95, you have a really pretty 2 different tails there. My sister, who does not look at the sky that often, called me up and told me there was a star in the sky that didn't belong, and what was it doing there? So they are visible with the naked eye. What are they made of? Dirty, snowy snowballs. The center of the nucleus is solid. It's about 5 miles wide. The coma on the outside of it is a blob of gas. As the comet gets closer to the sun, it's going to melt some more. And as it melts some more, you get more debris coming off of it. And as the debris come off of it, you get your tail. When you speak of the ion tail, think of a fluorescent light or a neon light. The gas particles are lit because of the heat and the speed and the friction that's going on. The vapors that have the solid frozen ice and chemicals, as it gets closer to the sun, they just sublimate. It's so hot and so fast that they skip the liquid state. They go directly from solid to gas. Scientists are interested in makeup of the comets because of they show us what the beginning of the solar system is. So we talked about the comets. We have the short period of comets that come from the Kuiper Belt, which is this area here. And then you have the long period comets that go out to the Oort cloud. Johann Oort had theorized the existence of the Oort cloud back in 1950, and the Dutch-American Kuiper theorized the Kuiper Belt. You look at this graph, it's not linear. It's called a logarithmic graph, so it's 1, 10, 100, 1000. And also they're using an AU, and we'll talk to you what an AU is. But basically there are two types of comets, short period comets that probably generate out here where Pluto is, and come into the solar system in less than 200 years, and then the longer comets that generate out in the Oort belt. Scientists like to make things very visual so they can see it in their mind. So we can say that the Earth is 93 million miles away from the sun, and we can say that, I forget how many miles Saturn is. But we created a unit of measurement called 1 astronomical unit, 1 AU, which is 93 million miles. 1 light year is 63,000 miles. So when you're talking about the solar system, we usually talk in terms of AU. And then once you get out of the solar system, we start talking in terms of light years, and a light second being 186,000 miles. A light second is not a unit of time, it's a unit of distance. The near-Earth comets are considered the short period comets. Any near-Earth comet that comes within 0.05 or 0.05 of an AU is considered a possible near-Earth comet, which needs to be watched at. And we will take a moment to celebrate Pluto. Today, 92 years ago today, Clyde Tombaugh out in Arizona found Pluto. It was there all the time. It was not lost. And what it is called doesn't really matter. It is definitely part of our solar system. And we will see that the names of objects do change over time. It is smaller than the rest of the planets. It is not in the same plane as the rest of the planets. And its orbit is more elliptical than the rest of the planets. And there are a whole lot of other stuff out in the Kuiper Belt. So the fact that they're calling it a dwarf planet does not make it any less important, and we must celebrate its anniversary. Okay, so we did comets, and now we'll talk about asteroids and meteors. Asteroids are rocky fragments, bits of rock that cannot be seen without a telescope. So in the 1700s, they figured out where Earth's now a solar center or heliocentric society. So all the planets are going around the sun. No one's complaining about the Earth being the center of the solar system. And they're looking at the planets that they know of: Mercury, Venus, Earth, Mars, Jupiter, and Saturn, which you can see without a telescope. And they decided that there's way too much space between Mars and Jupiter, so there must be a planet there. So they took out their telescopes and started looking. In addition to a planet there, they also thought that there'd be another planet further out. And Herschel found Uranus in 1781. And Mr. Piazzi found Sirius in the area of between Mars and Jupiter in 1801. So this is an actual photograph taken by the Dawn mission. Some of the pictures look really, really good, but they are actually not photographs, but just a really good artist's rendition. After finding Sirius, they found Vista. Nice size, fairly large. And the asteroids they were finding were not regular shapes. They were, some of them were round, but very few of them. Some of them, a lot of them look like dog bones. And it has to do with they're studying them with how they were formed, as you need enough mass in order to create that spherical shape. They have also found that there are about 150 asteroids that have moons, and they're called binaries. And we have Didymos and Dimorphos are one pair, which we will talk about later. Didymos, it's fairly, that is a picture, whereas Dimorphos is an artist rendition from the information that we have. Asteroids are defined by the type of material that they are made out of, whether it's rock and clay, some iron and nickel in with the silicate material, silicate being sand, or whether there's more nickel and iron than it is in volcanic gases. So they're divided up into their type, what they're made out of, and their location. And so you have the asteroid belt between Mars and Jupiter. Depending upon your screen, we have Jupiter actually has Trojans and Greeks following them. So you have some asteroids along the same path as Jupiter up here, and then some more up there. 90% of the asteroids are in the belt. And where are the other 10%? We found over 1 million of them. They range from sizes from several hundred kilometers, so a kilometer is a little over a half mile, to less than a half mile. The total mass of all of the asteroids is 4% of our moon mass. So there's not a lot. There's a lot of them, but they're not very massive. The 4 largest asteroids actually take up almost half of the entire mass of all the asteroids around. And Sirius itself takes up about 30% of the entire mass, which is why Sirius is now called a dwarf planet. It went from planet to asteroid to dwarf planet to keep Pluto company. 90% is in the area. This is a better picture of the Trojans and the Greek and the German. Occasionally, asteroids get pulled off their path by gravitational pulls of planets or comets coming by and moving them out of their way. There's also people believe that the moons of Mars had been asteroids, and then the gravitational pull brought them into the orbit of Mars. The other 90% are near Earth or close to Earth. The blue line here is the orbit of the Earth. As the Earth goes around, we have a bunch of asteroids in these locations that are intersecting and passing through our orbits. At one time, they were very concerned about Orpheus because it was coming very close. They knew that it was coming close. It's more than 1,000 feet. You figure the John Hancock building is under 800 feet. But having been studied, they know it will not hit the Earth. However, it will come between the Earth and the Moon, and the Moon is only 250,000 miles away. Asteroid belt, we have that covered. as the meteor, I'm sorry, as the comet goes through the Earth's orbit, we know that it gives off debris because it's melting and all that dust is coming off. And it leaves that dust in that spot in space. And so the Earth goes through that spot in space every year. And so this coming April, you may be able to see a meteor shower, which is where these meteor showers come from, comets debris, which was formed by the comet Thatcher. But Thatcher is a 450-year comet, so it's not going to be around for a while. But you will be able to look at the Lyre. Is the constellation. It's by the Southern Cross. If we have time, we can look at it on the star match at the end. So that's where we get meteor showers. Comet, dirty ice snowball. Asteroid, large rock, bigger than a meter, could be several hundred kilometers wide. Meteoroid is less than a meter, and a micrometeoroid is less than a quarter inch. When these particles, objects, whatever you want to call it, come near the Earth, the gravitational pull of the Earth pulls them in. They get pulled in. The friction between the particle and the atmosphere heats up the particle and starts to burn it. If it's a little grain, you see a nice little flash of light going by. If it's bigger, you can get as much as a fireball. And if it's really big, you'll get a bolide. If they're big enough, they'll just be a rock that lands on the ground. If they're really big, they'll either explode above the ground or hit and make a great big crater. How many do we get? We get basketballs every day, 2 or 3 basketballs every day. They don't always get down to the Earth, but they do fly in. And if you're lucky, you can see a meteor on any given night. Every month or two, we'll get a meteor the size of a car. But we're still looking for the other 10%, and we know where some of them have been. The Tuskegee event in 1908 took place in Siberia. There were several hundred people in the area, and they did get some verbal accounts from eyewitness 10 years later, because it took that long, 8 years for people to get up there. However, the explosion was heard by many people not in the area, and that the barometric gauges, the pressure gauges, were registering all around the world, so they knew that it happened. Now, we'll go to 47 first, 1947. In the mountains over here, Chakotay, Sakhalin, in Siberia, they had a very large iron meteorite. They've had iron meteorites in the past. Nothing was ever this large before. It was estimated to be 70 kilotons. And there's a whole lot of asteroids that remained in the area that was scattered around. And February 15th, over in the Ural Mountains, there was an asteroid that came into the Earth, and there was a whole lot of webcams, and for some reason the Russians were driving around with their webcam on at 9 o'clock in the morning. The asteroid came in at a very shallow angle. Where are we? Shallow angle. 90 degrees, 45 degrees, 20 degrees. So it's a fairly shallow angle. Most of the astronomers were looking at a asteroid that was coming between the Earth and the moon, so they weren't watching the other side of the sky, so they missed this altogether. As it came in, it was coming in at like 12 miles per second, and it ended up exploding about 10 miles above the Earth. And as it exploded, again, you have that massive pressure change when it explodes. There was a period of time when it was actually brighter than the sun. One thing to learn, if you see a meteor, open your windows, because the majority of the accidents and injuries was because of flying glass. But hopefully we won't have to use that bit of information. There are asteroids all over or craters all over the world. This particular one was found a couple of years ago using a GOI. It was mapping the Earth, and they found this little notch in the middle of the Egyptian desert. And they went out and they were actually able to find that it was a meteor crater that they did not know about, because nobody goes out there. It's a lot easier to find meteor craters and meteorites in the desert and in Antarctica than it is to find it in New Hampshire. So we'll never know if that boom we had last summer was actually a meteor or something else. But in this particular crater, they were able to find a lot of those iron meteorites. I lived in New York for a while, so I have to talk about the meteor that hit the car in 1992. In addition to the meteor in 2013 that they were watching and predicted that it was going to go between the Earth and the Moon, the first time they were able to predict an asteroid was in 2008. And they found the asteroid and did their calculations, and it hit pretty much where they said it was going to hit. And the event that we all learned 66 million years ago, a mountain-sized asteroid slammed into the Earth off the coast of Mexico's Yucatan Peninsula, jamming the dinosaurs and leading to their extinction. The collision was cataclysmic, triggering tsunamis along the coastline and firestorms. The impact also affected the dust and vaporized the rocks. Those rocks had sulfur in it. The sulfur became sulfuric acid, and it was not a very nice place to be shortly after that. This is a report from 1988 through May of last year, which came from a DART presentation of all of the meteor hits that we are aware of. That one being the one in the Ural Mountains in 2013. So there's a plan. There actually is a planet defense system. A planet defense system is an organization by NASA. It is in coordination with international space agencies and governments. We have to look for them. We have to study them on Earth and in the with satellites, and then we have to mitigate. FEMA is actually doing exercises. They pretend they're having an asteroid is going to hit, and they do these exercises to figure out what one would do in case of an asteroid hit and how to deal with it, so that we don't become a Bruce Willis movie. So we'll talk about characterization and WISE first, and how they go about doing things. The Torino Scale is what helps rank the asteroids, so that we're not studying all of them all the time. So they have them by size and location. They need to be 1.3 astronomical units from the sun. That means between just a little between us and Mars and to the sun. Comets have to be a 2-year a 200-year short period comet, and also come within 5/500ths of an AU towards the Earth. The potentially hazardous comets and objects have to be bigger than 460 feet and 5/100ths of an AU. I read that wrong. And 5/100ths of an AU is 4,647,790 miles. So 5/100ths of an AU, 0.05 AUs, is just an easier number to understand, to get a hold of. More than 1 million asteroids have been discovered. They believe that they know 95% of the larger ones, anything greater than a kilometer. Once an asteroid is discovered, we calculate where it's going to be in the future using the different rules. The discovery of an asteroid and deciding the size of the asteroid is a different issue. We're looking at these two asteroids, which are with visible light. Those are the colors that we see. And with visible light, we have these two asteroids, and they look pretty much the same. WISE, Wide Field Infrared Survey Explorer, otherwise known as WISE, which had a second life as NEOWISE, can look at these two dots, and we can see that they are actually very different. One is extremely reflective in visible light, whereas the other one is not reflective in visible light. And this is what they actually look like. So we can figure out which ones are big and which ones are small. The nice part about this, using the infrared, is that it doesn't show us more stuff. It actually shows us less stuff, because we can differentiate. On the right, you see a model where you have the visible light, and you're looking at it, and then with the new modeling, you can get rid of 16,000 possible objects that are actually going to be close to Earth. And then another example of why using different wavelengths of light to look at things is very useful. Using visible light, you have a really big something and you have a really small something. And when you look at the same three objects in infrared light, they're pretty much all the same size, and that's due to their makeup and their reflective abilities. Before we leave that, we not only use infrared light, but we also use X-rays, radio waves, and so you use the various different electromagnetic waves as telescopes, effectively, to get different information from the objects that we go to DART, Double Asteroid Redirection Test. They wanted to find a way to practice moving an object without causing more damage. So they decided, well, we'll take a little solar system all into itself. So they chose this binary, which I showed earlier, Didymus and Dimorphos, and they've been able to study it because it comes fairly close to Earth. So they can see it visually for a good portion of its orbit. Didymus is 160 meters. It has an orbit of 11 hours, so it goes around every 11 hours. And then we have the DART, which was actually launched on Thanksgiving Day. And we'll do a little video here. This technique is used to find exoplanets originally also. So you don't actually see what you're looking at. You look at the light, you look and you measure the amount of light coming off of the main object that you're looking at. And then as the light changes, you measure the amount of the change of the light. And in doing that, you can then calculate the size of the object that's going around, the length of time it takes for it to go around, and get all sorts of really cool information out of that object. And they were able to do that, so they have all the data they need ahead of time. This is another graphic from DART. The Earth and DART and Didymus are going around one another, and Thanksgiving of last year, they launched DART. And come October of this year, the Earth, Didymus, and DART are all going to come together. And we're going to be able to watch it from Earth. And we'll do one more graphic. And these are graphics. These are not live pictures. Didymus goes around. And as this goes around, we have a DART coming in, and that's fun. What happens is there's a little door. There we go. There's a little door on DART that just opens up, and they drop this camera out, and then the camera opens up its solar panel to give it power as DART crashes into Dimorphos, so that 3 minutes later, the camera comes and takes pictures. We're not really concerned about how much how big the crater is. They don't think they're going to be able to get a crater picture out of that, but they will be able to get a picture of what Didymus looks like. I'm sorry, Dimorphos looks like 3 minutes after impact. So why would it be different? If you have a cue ball, it's going to be hard, it's going to be solid, and if you give it a nice little tap with another ball, it's just going to move a little bit. You know, there's just one tap, action and reaction. It's going to, the amount of energy that gets put in is going to be the amount of energy that gets put out, unless there's friction and you're in space, and so you don't have a lot of friction. However, if it's a amorphous, we missed a picture there. You get the idea. You hit it here, it's not particularly dense, but it's not particularly granular, and it will go up, and then it will have this little jet reaction that will push it forward. And then if it's more porous, you're going to get a larger jet reaction, and it's going to get pulled in, which is why, yeah, they want to measure this new orbit afterwards. And that's the important thing. They'll be able to figure out how far the Dimorphos had been moved and where the orbit put it, or where the new orbit would be. The camera is a camera that they borrowed from the Italian Space Agency, and it's a nice little device. It's a fun little device. It opens up, and when it's stowed, it's just a little rectangle, and then when it gets literally dropped into space, it opens up its solar panels and then gets energized and is able to move that. So you have NASA is doing the intercept with JART and is actually going to hit the planet or the asteroid in this coming fall. And then the European Space Agency is following up with their satellite, and they will be going to the same binary in order to get better pictures, up close pictures, so that you don't have to rely entirely on land-based observation. This is not a, we say NASA, but in actuality, this is based on a John Hopkins idea. And all of these institutions are working on the DART project, in addition to the European Space Agency is collaborating as well. So that's the talk. We have a couple minutes. I'm a hardware person as opposed to it, so I always like looking at the different toys that are on the spacecraft. So there are various different technologies that are being used. If you're interested in the meteor shower, that's going to be the end of April of this year. Vega is the star, the Lyre is the constellation, and the meteor shower called the Virids. And it will be more or less in that area. Going to be pretty close to the horizon. And this is like 10 o'clock at night. And there's also a moon coming. So this may not be the best time to look for them. But anytime you want to see a meteor shower, they're all labeled online as to when the showers are available. And depending upon your location, some of them are better than others. And there are actually other showers that you could be seeing in late April, but they're of various, they're not part of the comet showers. So there's the polar star, pointer, Little Dipper, pointer star, that's the north. And then this would be part of the summer triangle, but it's not all up yet. And then the other thing which I skipped. So this is not an actual asteroid, it's just a make-believe asteroid. It's 50 meters. Yeah, so you figure it's a little bigger than a football field. And if we pretended that a potato is your average asteroid, where would your next asteroid be in your, if you're in the asteroid belt? You know, maybe we'll just stop here and people can put in guesses. Where do you think the next potato would be if you're in Tewksbury, Massachusetts? Doc, Robert? Well, call it Doc.
I'm sorry, Regina. It took me a second to unmute.
Right.
Yeah, let's hope the potato doesn't hit us in Tewksbury. That's for sure. So, Regina, are we okay now to go to Q&A or?
Yeah, we're okay to go to Q&A, and if anybody wants to talk about where they think the potato would be in the asteroid belt, if they're in Tewksbury, Massachusetts, they can put in a city or a town in the Q&A.
Okay. So an anonymous attendee asks, what about a couple of questions here? What about Starlink satellites? 40 Starlink satellites doomed by geomagnetic storm a few weeks ago, around the beginning of February. And then I don't know if you mentioned this one, but I guess I heard about this on the news a couple nights ago, that there's a I don't know, a Chinese rocket that's going to hit the moon in a couple of weeks. Have you heard about that?
Yeah, well, they're not going to hit the moon. They are going to the moon to, I believe they're going to try to collect some more data. Didn't actually read up on it, but yes, I did know about the Chinese having a satellite going to the moon. And no, I do not know anything about Starling. I did not read up on that.
Yep, no worries. All right, so Frances says, thank you, Regina. Renee says, welcome, yay. Gail says, thank you. Does anyone have any other questions or comments for Regina before we head out a couple minutes early here? Renee says, meteor showers are predictable and consistent. Why does the solar wind not blow the debris field dust?
I'm sorry, why
yeah, I didn't word that correctly. So she says meteor showers are predictable and consistent. So why does the solar wind not blow the debris field dust?
The solar, well, they're going to, yeah, the solar winds kind of, yeah, that's a good, yeah, they don't. The solar winds will blow the tail, but the dust is still going to sit there in the particular area. They're not going to get, because they're really small. So yeah, Mark? It doesn't. I don't know why it doesn't.
That's okay. Mark says, thank you. Jody says, great talk. Enjoyed the new information. Thank you. Catherine says, thank you so much. And yes, Catherine, I'll send you the recording. Teresa says, thank you. Olga says, can this talk be available as a recording, please? And yes, it will be. You'll be receiving it from me this afternoon via email. Let's see, Mike asks, can you say more about the asteroid that was a planet, then an asteroid, and now a dwarf planet?
Oh, sure, we can go back to that slide. Cirrus. Back. Oh, here. Well, I'll escape out. I'll escape out. Oh, that gave it, and we can go back to Cirrus. They needed telescopes to look for asteroids, and they thought that there would be something between Earth. Between Mars and Jupiter, but they didn't know what that something is. Cirrus, being the largest of the asteroids, remember it took 1/3 of all the asteroids combined. That's how massive it is. Was found first. It was found first because you could see it better. This again is an actual picture and not a graph. When they found it, they said, we're looking for planets. We're calling it a planet. It's the first one and the only one we have. So now we have an extra planet. Mercury, Venus, Earth, Ceres, Mars, Jupiter, and Saturn. And actually by that time, they also had Uranus. It was 5 years later, or 45 years later, when they ended up with 40 more planets, that they decided that planet is really not a good name for all these objects that they're finding in this space. And so they named it Asteroid. After Pluto was studied, and they realized that its orbit is different, its mass is different, they defined Dwarf Planet as a round object of a certain size with a certain orbit. Well, planet is the wrong word. Object is probably a better word. And so they defined dwarf planet, and Cirrus fits into the definition of Pluto's dwarf planet definition that was created for Pluto. So again, scientists like to put things together. It's easier to study them that way. And that's why they changed the name. It's just a classification. It's like libraries are doing away with the Dewey Decimal System and going to the new system.
Well, it's interesting you mentioned that, Regina, because we're actually in the process of going from Dewey to the new system called BISAC
Yeah.
here in Tewksbury, which is like, originally I thought that was sacrilegious to abandon Dewey, but I think we're doing the right thing here. I think people will people will like the finished product. Has your library gone to BISAC or something else?
No.
Not yet. Yeah.
No, not yet.
Gotcha. All right. Well, Kristen says thank you. Renee says awesome talk. Phil says if the comet is a potato, I would guess the next one will be in Boise, Idaho. There you go. A little humor. Bernard says very informative. Molly asks, is the purpose of the dart just to see what the asteroid is made of, or is its purpose to knock it off its orbit?
Knock it off its orbit. A redirect. DART is a redirect mission. So they want, the idea is they want to know whether, how they were, if there was an asteroid coming to Earth, how would they hit it so that it would go someplace else and have it controlled? Because you don't want to just hit it and have it go someplace else and hit something else. So the object is to hit it and to see where it goes. Osiris-Rex is a program from NASA that has already gone out to the asteroid Bennu and touched down on the asteroid Bennu a couple of times, picked up 4 pounds of Bennu's surface, and is bringing it back to Earth in a little Amazon box, I guess a NASA box. And it's going to, in a couple of years, it's going to drop it on Earth, and then they'll have the box of Bennu to study. But no, we're not looking at the surface. We're actually looking at where the smaller asteroid is going to go in relationship to the bigger asteroid.
So Mike asks, is it really worth spending money to protect ourselves against asteroid collisions?
Yeah, that's a good question. It's as I was asked once before, many years ago, and if for a moment I thought the money spent was going to go to world peace and feeding the hungry, I'd say, do it, but that's not going to happen. And I think it's important. Knowledge is always important. Useless knowledge one day becomes very vital the next. When I was in the semiconductor industry, we were doing research and development, and a lot of the stuff we were doing was just science, which we were pretty lucky because most industries nowadays can't do that. And the science we were doing was pretty useless at the time. And 10 years later, it became the foundation for the telephones we have today. So studying the asteroids now, trying to figure out a defense system, it may seem a little Star Wars, but having the knowledge is not going to be a bad thing if we're going to need it someday, and somebody's going to find a way of using it. So yeah, it's a good argument, but I think it's important to study things for the sake of studying them. You got to remember that Newton was rich and studying was a leisure. It was not, you didn't go to school to learn things. Only the rich went to school, not because they were rich and could afford it, but they had the time. They did not have to farm the field and cook the dinners. They had the time and the leisure to study. And I think even in today's day and age, we need to take the time and study things that may not be, pertinent at the moment, but could be very useful in the future.
And let's see here. You referenced Bruce Willis and the Armageddon film. I'm curious if you've seen the recent Netflix film entitled "Don't Look Up." Did you happen to see that one?
No, I have not.
Very polarizing. People either love it or hate it, but I think you might want to take a peek at that one. Mary asks, how fast do the asteroids move, and how much warning are we likely to have before one is headed for Earth?
warning, we hope to get 10 to 15 years, and we need 5. So that's a number that I remember. And how fast are they moving? It is in one of my slides. And I don't remember.
Yep.
Yeah.
Margaret comments, ask the dinosaurs if it's worth spending the money on preventing asteroid collisions here. 2 more quick questions. If we monitor objects, how do some sneak up on us shortly before it comes so close? I mean, you just referenced 10 to 15 years, but I feel like sometimes we find out about things a lot sooner than that.
Well, yes, we do find things a lot sooner.
Or later than that, I should say. I'm sorry. You know what I meant.
Well, with as of now, we're looking at so many things, and we just got another telescope on, which came in the news last night, so I didn't get it in the talk. But there's a new telescope that actually, we were doing the Northern Hemisphere with 2 telescopes in the Northern Hemisphere, but Chile and South Africa just came up with their telescopes, so we can get the entire sky every day, which is something that did not happen prior to this week. So with that in mind, we hope to find things, 10, 15 years out. There's one asteroid that's, 2182 that they're looking at, that's the year that if it were going to hit, it would be in 2182, but they don't think it's going to hit, but it's the closest thing. And so they're looking at that. So we're talking a few years out. The 10 to 15 years is that's what they need to know in order to do something about it. Does that answer the question?
Sure. And let's see. We'll ask James' question. Will wrap us up as we've reached 12 o'clock. How many man-made objects can we see with the naked eye? And is there any one that is particularly noticeable?
The International Space Station is very noticeable. It reflects the sunlight, so you're going to see it at sunset and sunrise, and a couple hours after on either side. That too, you can look up on the web, and it will tell you exactly where and when to look at it, because it's not visible all the time. And I have not seen any of the others, so I don't know if they're visible. I haven't gone looking for them. And by the way, the other potatoes would be in Washington, D.C., Rochester, New York, or the Maine Canadian border. So although there's a lot of asteroids out in the asteroid belt, they're not very close to one another on a regular basis.
There you go, Regina. I didn't even want to offer a guess. I knew I'd be way off. Shane says, nice program. Thank you. So why don't we wrap it there? Do you have any last words for the group before we wrap up?
The words of the Florida astronomer, keep looking up.
All right, there we go. Well, thank you all so much. Thank you, Regina. Look for an email from me later today with a feedback survey, a recording, and information about next month's NASA Solar System Ambassador Program. Thank you all and have a great day. Thanks, Regina. Nice to meet you.
Nice to meet you. Thank you for having me. I enjoyed it.
Great. Bye.
Bye.